Hi, my name is Jasper Schomaker. I'm a sophomore here at Mizzou. The current date right now is 10/13/21, and this is my submission for our second direct engagement in Finite Math, or Mathematics 1300 here at Mizzou. I'll hop right into it here. So starting off, we have the problem that I'm sure you are already familiar with, and I am as well, so I'm just going to go ahead and jump right into the questions. So what we are asked to solve here with this multi-part linear programming problem is first 6 inequalities that are associated with this problem. So we take the factors that are given to us in this text up here, and we implement that in the form of inequalities. So starting off, let's see, our first inequality, we know that at most $3,000 more than the medium risk investment must be put into the low risk investment. So here we have the total for the low risk. We know that has to be less than or equal to whatever is in the medium risk bracket plus $3,000. So that's our first inequality. Secondarily, we know that at least $5,000 has to be invested in low and medium risk stocks. So we get that by simply adding those two values together and knowing that they have to be greater than or equal to that $5,000 mark. That's our second inequality. Our next two inequalities are fairly simplistic. We have one with medium risk and one with low risk, and basically all we're saying here is that they both have to be non-negative. This is also true with the high risk investment. So the first two are fairly simplistic because we already know that our variables here are x in the amount of low risk and y in the amount of medium risk. But we don't actually have a variable designated for high risk because this is a simple inequality. And going down here, so we say high risk must also be non-negative. So we know all these things must be non-negative. They can be 0, but they cannot be below 0. So being that we don't actually know the high risk investment, we just have to take that $15,000 that Ms. Smith was immediately given to invest with. We subtract out the low risk investments, and we also subtract out the medium risk investments, and we know that those things all together must be greater than or equal to 0. For our last inequality, we know that no more than $13,000 can be invested in both the medium and high risk stocks. So similarly to the $5,000 limit on the low and medium risks, we must just add all these things together. So we have y, our variable for the medium risk stocks, and we have to add that together with our variable, or equation rather, for the high risk stocks. So that's y plus 15,000 minus x minus y, and we know that all that together has to be less than or equal to $13,000. Simplifying all of that out, you get here, so instead of simplifying, okay, so in order to simplify this out, you cancel out your y's here, you move your 15 over, which would get you negative 2,000, and then you're left with this and this, so you simply divide each side by -1, flip it over, and this is what you're left with. For the second problem, we are asked to write the objective function for this, and we know that the rates stand at 6%, 7%, and 8% respectively for low, medium, and high risk investments. The objective function then, with the goal to maximize the rate of return within the given constraints, we're going to use a to represent that objective here, is going to be a equals 0.06 x plus 0.07 y plus 0.08 this here. And so if you don't understand any of these, this is the low risk times the low risk investment variable, medium risk times the medium risk investment variable, and how you would calculate out to get the high risk and the high risk investment variable. Simplifying all of that out, you're left with a equals 1200 minus 0.02x minus 0.01y. Next, we're asked to take these inequalities and graph them, labeling the feasible set. Didn't have enough room on this page, so I went ahead and moved on to the next one. Here, you'll have to excuse my graph. It is kind of lopsided. I ran out of space here towards the end, but you get the general idea. Here are all the constraints and inequalities off to the side. I can go through here and identify them for you. I know they're not explicitly labeled, so this one here is going to be this line right here. This line here is along this axis. This line here is along this axis. we know that, so that leaves us with these three lines right here, here, and here. We know that this last one is this line right here, and we know that this line right here, let's see, this line right here would be this line, and this secondary line would be this line right here. Yeah, I believe so. So then our last question that we are asked, and I do apologize, the feasible set here is shaded in red and the vertices are all labeled here on the graph. But in order to answer that last problem, the vertices are labeled here as 2, 13, 2, 3, 9, 6, and 4, 1. Thank you again. This is my submission for the second direct engagement.